My name is Rob Dudley. I'm your third speaker for the evening. A bit of information about me up there. The only important thing you need to know is that I'm looking for people Total Geek absolutely love gadgets, computers, software development and all things associated with it. If anybody wants to know how to shout at me professionally, I am responsible for the technology behind Quidzin. Please hold all heck until the end. Quick straw poll. Hands up if you've heard of a Raspberry Pi. And keep them up if you own one. Not too shabby. Keep them up if you've done lots and lots of really cool things with it. Okay, you can just doze off up the back there, you're fine. For those of you who haven't seen one, this is a Raspberry Pi, revision 1, Model B. So if you want to just send that round and you can have a look, don't worry, you can't break it. A little bit about what the Raspberry Pi is before I get into the amazing 10 things. Ready up to the start timer. It is fundamentally a small computer that has been designed to plug into either a TV or a monitor. Now, TV in this case can actually mean both a modern flat screen. It can also mean one of your old CRTs. So it's been designed really to work with pretty much any kind of display technology you might have kicking around. They are cheap. If you consider a new laptop these days, will set you back about 250, 300 quid or more if you want something half decent. A Pi is £25. And yes, you need to spend a bit more to get it up and running, but base price, that's not too shabby. They have shipped over 1 million units since they launched. It uses a system-on-a-chip. Won't bore you with the technical details, but suffice to say this is the living, beating heart of the Pi. It's CPU and it's RAM, and I think it's graphics controller as well. All baked into one. It's the Broadcom BCM2835. Don't you feel better for knowing that? They were designed as an educational project by a bunch of clever chaps from the University of Cambridge. And to that end, they were launched. But they've kind of taken the imagination of technically inclined people around the world, really. Quickly run through what's inside a Pi. That is a Pi board, and this is what's in it. It is powered by a micro USB connector. The reason that's worth noting is because the same kind of power connection is used for an awful lot of mobile phones, so the odds are very good that you already have a charger that is capable of running a Raspberry Pi. Audio and video, as I've already said, you have HDMI, which will run through your new televisions. You have RCA video, which works brilliantly with older TVs, especially after the digital switchover. There are tons of these things kicking around that aren't being used. They can now be used with a Raspberry Pi. Audio, you've got a standard 3.5mm audio jack, and of course DVI is also capable of carrying sound. Okay, connectivity. On the Model B, you have two USB 2 ports, you have fairly standard Ethernet, and you have GPIO, the general purpose input and output pins I'll talk a bit more about in a bit. Just a quick run through the internals. There's that amazing BCM2835 bang in the middle of the board. That comes with, depending on which version you get, either 256 meg or 512 meg of RAM. That's your first clue, if you haven't worked it out already. These are not super powerful computers. They run at 700 megahertz. That's still 10 times more powerful than my first computer, but still. We also have a LAN controller chip, so you know where it is. You have debug ports, so you can hook up to a USB or any other JTAG device. And now it starts getting interesting again. You have a CSI, which is not a really dodgy American TV show, but is in fact a camera interface board, and you have a display interface board. Now, only one of those two is currently in use, at least actively in use. The camera display you will see later on. The display interface, not got a clue what they're planning to do with it, but it'll be interesting to find out. Storage is via SD up to 32GB SDHC, so standard SD card. Realistically, you already have a bunch of components that you can just throw together when you get your Pi. You can probably get the thing up and running fairly quickly. I have a confession to make. This was billed as 10 things to do with the Raspberry Pi in 10 minutes. The original version of this presentation was in fact just that. However, since then, I've kind of got a load of new stuff, and it actually runs a little bit longer than 10 minutes. I could do it in 10 minutes if you want me to rush, but does anybody mind if I take a little bit more time? No? Fantastic. So, 10 uses for a Raspberry Pi in about 10 minutes, give or take. And I'm going to do my best to jump between the two screens. We're going to start with number 1, This is not exciting. Sorry, the guys sat in the corner, you might struggle to see this. I'll try and get out of your way where possible. Is that a bit better? Yeah? Okay. And up comes the Pi. And all I'm about to show you, in fact, whilst I'm waiting for it to load, is the fact that the Raspberry Pi is capable of running a full Office suite. This is not Microsoft Office. This is LibreOffice, which hopefully is installed on here somewhere. Okay. And let's go for the interesting one. LibreOffice is what used to be OpenOffice. It was forked. It is a completely open source office and productivity suite. It includes a spreadsheet application, a word processing application, a slideshow application, and a load of other stuff as well. Fundamentally, this is Word, Excel, PowerPoint Access, all rolled into one, all running on a computer that costs 25 quid. It might be a little bit slow to start up, it might be a little bit clunky to use, but it works. So you've got word processing that needs doing, a mail merge that needs sending out, you can use your Pi to do it. I'm not actually going to show you me using Excel, me using LibreOffice Calc, because that's probably the dullest thing I can think of. Much more interesting is number 9 on our list, software development. Now this is really the reason that the Pi exists. The Pi's name is derived from Python, the programming language. It's also derived from Monty Python, and it all gets very confusing. Your Pi comes complete with a couple of different tools, one of which being Python. In fact, you've got 2 separate versions of Python, a very common programming language. And if it ever loads, there we go. 1, 2, or 3, we'll find out. Okay. Again, I'm not going to dazzle you with my amazing Python skills. They are brilliant, by the way. Suffice to say that on the Raspberry Pi you have both Python 2.7 and the newer Python 3. And those are baked in. Those come straight with the operating system Raspbian. The other thing that you have, which is slightly more interesting, is something called Scratch. This has been developed by a bunch of really clever people at MIT. Now, Scratch is designed to teach younger children about the concepts of software development, so logic, looping, events, and what have you, and to do so in a fairly fun environment. It's fairly drag and drop, and you can actually do all sorts with this. Would you believe it, not being a primary schooler, I haven't done masses with Scratch, but I have it on good authority that some local kids are really, really into this. In fact, so much so I can't even work how you run it. Yeah, no, but there you go. That's right. Notice next time you're going to do a demo, actually use the demo program. Okay, we're moving on fairly quickly to number 8. Number 8 means I have to log out. It's a games console. I'm not talking about a PlayStation 4 or an Xbone or some stupid thing with high-definition graphics that's capable of producing mind-numbing inanity at 70,000 frames a second. I'm talking about vintage gaming. I'm talking about the Nintendo Entertainment System, the Mega Drive. You know, anybody here born after about 1996 is going to look at it and go, what? In fact, you can go further back, to be honest with you. What we have available on the Pi is a plethora. There's the SNES, Mega Drive, Spectrum, ZX Spectrum, a Game Boy emulator, it's not quite portable, an Amstrad, there is a BBC emulator. Very quickly, and I'm not going to sit here and make you watch me play Mario Kart. But just as a quick demo. Now, if you happen to have a USB gamepad, and I'm sure that you can find one kicking around, if not, you can make one, you can plug this in, play. Right, there we go. Sorry. It's right, we'll go for a panel mode after we're done. Yeah. Okay, I need to run this again, and let's go back into X. There we go. Right, number 7. Hands up if you've heard of Minecraft. Hands up if you actually know what Minecraft is. Right. Here's what I think Minecraft is. I think that Minecraft is virtual Lego. And I think it is absolutely fantastic. For those of you who don't know what it is, don't worry, you're about to find out. Basically, it's a block placing game developed by a bunch of very clever guys from Sweden, I think, and now around Europe, called Mojang. And if I can find it. No. There is a specific version of Minecraft that has been developed purely for the Raspberry Pi. Okay, that is Minecraft, and I can jump into my world. Now, why is Minecraft exciting? Aside from being quite a cool thing to do, be able to run about this virtual world and build things, there's been an awful lot of research recently as to how Minecraft as an educational tool can help those with learning difficulties, with perception difficulties, spatial and colour awareness and what have you. The version that ships with your Pi, which may or may not have a little house that I spent far too long building instead of practicing using Scratch last night, there we go, actually comes with a full set of scripting support. Now, if anybody knows anything about the original Minecraft, it's built in Java. This version can be extended by Python, which means that effectively, when you're done building your little house and what have you, you can write a script that makes the lights go on and off. So it actually starts to join up a fantastic learning game and a fantastic environment with the software development side of things. Again, anybody who wants to build a house later on, feel free. And if I can work out how to close this. There we go. Okay. Moving on to number 6. Number 6, there's no tech demo for this one. There was no point. The only thing I'd be able to show you was my IP address changing. Because of Raspberry Pi's small form factor, I don't know, who's got the one that's going round, by the way?
Yeah.
It's in somebody's bag. Because of its small form factor, and because of its low power draw, and because of its connectivity, you can actually turn one of these into a wireless router, which has quite a lot of power, to be honest with you. If you consider most wireless routers are incredibly underpowered when compared to a Raspberry Pi. When you have something that's operating as a router, the next logical step, well no, the next available step is to actually run a piece of software called Tor. Anybody know what Tor is? Hands in the air. Awesome. For those of you who aren't those people with their hands up, Tor is an anonymizing peer-to-peer network. There have been a load of peer-to-peer networks tonight. This is another one. And effectively, it was developed to allow individuals in locations where internet access may be monitored or censored, to communicate with the outside world without fear of censorship or suppression. It is perfectly possible, following a series of fairly simple steps, to set up a Raspberry Pi as an easy-to-use Tor router. At which point, you can pretty much, from anywhere in the world, whether you're a journalist in China or over in the US, it's not like the NSA are watching anything these days, you can communicate with the outside world with a relative degree of anonymity and safety. The one thing I would say, just to preempt the question, Tor, a bit like Bitcoin, has kind of a murky underbelly. It is about anonymity. It is an open software platform. Yes, you can use it to hide yourself and do naughty, nefarious things from the shadows. The reason the project exists and the reason I'm highlighting it is because fundamentally it is about a tool for freedom of speech. Okay, this is me getting off my soapbox. Number 5. Have I got a reboot? Yes, I have. Right. Talk amongst yourselves. I tried to keep these to a minimum. Number 5, home theatre PC, HD PC. Believe it or not, in a device that is as diminutive and seemingly underpowered as the Raspberry Pi, it is actually capable, after a fashion, let's get there, there we go. It is actually capable of running a piece of software called the Xbox Media Center, which has nothing to do with the Xbox or Microsoft. What this basically means is that your little Raspberry Pi becomes a PC that can sit under, over, frankly you can blue tack it to the back of the telly, and it is capable of playing full HD video from certain formats. It is capable of streaming BBC iPlayer, 4OD, Netflix, all of your online services. It is capable of playing back internet radio from a vast range of places. It's capable of playing back MP3s. There we go. Ooh, easy. Calm down. It is capable of playing horrific music. Or at least it could be, if it would behave. Anyway, stop this thing. Right, that was easy. Note to self, if you set up a media player, make sure you've got a remote handy. Right, we'll just wait for that to reboot, because you see, is actually going to bring me on to my next slide, which is kind of a funky one. And this is a couple of enterprising open source hardware and software guys in Europe have managed to make the Raspberry Pi the brain of an automated bartender. I'm just going to let that sink in. A 25-pound computer can now mix you a mojito with a ton of additional hardware around it.
I think you've just upset it out there as well.
Okay, I'm actually going to play this through. I might interrupt it, to be honest with you, because they do go on for a bit. But fundamentally, this is an example of the Pi playing back a reasonable resolution movie, and also this is the Bartendo.
Hi Kickstarters! We're really excited to introduce you to Bartendo. Bartendo is a fast, portable, precision cocktail mixing robot that you operate with your smartphone or tablet. It works great for parties, for events, or just at your home. All of our bots are going to be open sourced. All of the hardware, all of the software is going to be open sourced, and we're really hoping that you will take part in this project and help us to actually make these bots even better. Hi, I'm Rob. I created Music Brains, and I've got 20 years of experience working with software and more than 13 years of experience with open communities.
And I'm Pierre. I've designed robot electronics for more than 7 years, and Rob and I have been working on a ton of projects over the years. You may have seen our latest Make Magazine article where we show you how to make a water cooler turn water into wine. Pretty fun. About 5 years ago, we started thinking about how to dispense perfect cocktails. I was more of a beer and wine guy. I liked cocktails, but they seemed a little unapproachable. Whenever I was going to make a drink, it was messy, and I was always wondering, is this what my drink is supposed to taste like? So we set out to make a robot that would automate the pouring and get rid of the guesswork and the messiness. The technology is available, so we were wondering why other people hadn't done this. Well, it turns out it's a much harder problem than we originally thought. There's parts available out there, but they cost well over $300 for one pump or one sensor because they're industrial or medical grade, and there's not much to cater to hobbyists. So I ended up getting a CNC milling machine and putting it in my garage, designing and machining several flow meters and valves and pumps and other sensors, and we're making a new bot every 6 months for the last 2 years, trying to figure out all these new concepts and really nail the design. And we think we've finally gotten there with these peristaltic pumps. They're amazing. And with a few modifications and our custom electronics, we can measure fractions of a revolution to dispense a known volume to within a milliliter. We hope you're going to love it as much as we do.
That's Bartendo. Number 3, camera. Right, in fact, because they've started it, we talked an awful lot about the software side of the Raspberry Pi applications you can install, different distros, in fact. Expion, which was running that movie, is a whole distribution you can install straight with an SD card. We are now moving into the wonderful world of hardware. And as a result, safety first. Okay. You have to bear with me whilst I'm wearing this, I need to connect up the camera module. This doesn't look silly, does it?
Not at all.
Okay. What I'm actually doing, and I'm afraid that you can't see it because it's kind of fiddly, is hopefully connecting up the camera module to the CSI port that you saw earlier. I'm also going to jack this little collection of things, which looks an awful lot like it may explode any minute, into the GPIO for the demonstration that comes after that. And I'll talk to exactly what that does when we get there. So you want to actually get that thing right there. Should we go to those? Okay, I think that's good. see if any of those fizz pop want to power it up. No, we're good, we're booting. Awesome. Right. So, a quick explanation about the camera module, for those of you who haven't heard of it. It is basically tiny, and I mean tiny. For those of you who can actually see it, it is yay big. Kitchen, so about the size of, I suppose just under the size of a 50p piece. It's connected by a ribbon cable to the CSI slot. And this is actually a full HD camera, capable of HD video and HD still photography. Now, I'm not going to bother too much with the video, because frankly, I don't really have anything that interesting to film. Sorry. But I am going to see if I can get a couple of still shots, just so that you can see the kind of quality we're talking about. So if I jump back into the Windows environment. Okay, where am I? Okay. Where's my still? Right. Everybody say cheese. And there we go. I appreciate it may not look like much, but after a fashion, there is our lovely photo. Sorry, it takes longer to load than it does to take. One thing I will quickly point out is that that picture is 2.8 meg, it's huge. Let's see if we can fit on screen. If not, then you're just going to have to take my word for it. No. There we go. Forgive the shakes, obviously I'm rather nervous. The Raspberry Pi module is exciting for a couple of reasons. Firstly, because it is the first accessory that has been released that's been designed specifically for the Raspberry Pi. I mean, there have been cases and what have you, but this is designed to go straight onto one of those extension boards. The second reason is it's light, it's tiny. The third reason is the price. That camera costs about 15 quid. So you've actually, if you consider that you can combine the Pi and the camera for about £40, he's just checking his maths, yeah, give or take, you have a machine that's capable of doing relatively high definition video conferencing. It can certainly do stills photography, it can take reportage, journalistic video, probably you don't need a zoom. It's pretty much endless. One of these cameras has already been sent up to near the edge of the Earth's orbit, along with a Pi underneath it. I hasten to add, they didn't just chuck it out the window. On a weather balloon, and has sent back some amazing shots of the curvature of the Earth as seen from that distance. When you consider that they're doing that with a bit of kit that costs 15 quid, it's quite impressive. Number 2, the clock. Okay, it is not that clock. It is in fact this clock. I'm going to have to be careful to make sure that you can see it. The clock was built primarily pants and have been completely badly attached, so bear with me. There we go. The clock was built as a demonstration of how you can interface with Pi via its GPIO. Remember those pins you saw? Now those contain all sorts of lovely goodies. Give me a second, I don't need to go back into X to do this. Some of the goodies include, it's got a full serial bus in there. It's got an IC2 bus. I'm not too sure what an IC2 bus is, but it sounds cool. Long story short, if you wanted to extend your Pi into the realm of hardware, you're normally going to be messing about with the GPIO pins. And fortunately for me, there was a nice, easy setup. I don't know if anybody at the back can see that, because there's a ribbon cable in the way. But basically, that is a standard prototyping breadboard, just a series of little holes that are all linked by circuits. A number of male-to-male jumper leads. This little bit is the only bit that's even particularly fancy. It's called the cobbler, and basically it gives you an easy way to get the pins from the GPIO onto your breadboard. and this is a LCD display. So, what this should do, if I can actually find the program, yay. Right, this is going to be hilarious because one thing I will just mention. Where's my it's embarrassing, bear with me. Yep. Yes, okay. Sorry, right. The reason this is going to be embarrassing, apart from the slight delay whilst I loaded the modules that I need to actually talk to ICT Bus, is because the one thing the Pi doesn't have is a real-time clock. As a result, I'm about to show you an amazing clock demo that will have completely the wrong time on it. Normally, the time on the Pi would be set via communication with an NTP server, which it would happily do if it could get on the internet, which it can't in here, unfortunately, because it can't get past the yes, I want to go on the internet screen. So, it's not far off, actually. I don't know if you can see that. Yeah, a fair bit of code and a fair bit of wires and what have you to basically recreate about a £2.50 radio. That's not the point. The other thing that you can do is there's a little button here that should click me through to second display and then back to the time. The important bit to remember is that that little module there is not a clock, it's just a display. All of the processing that you just saw, all of the switching and what have you, is being handled by software running on the Pi, specifically fancyclock.py. I've got one more example, which really worries people. Basically, that's just going to count down now. If you can make it beep as well. No, anyway. And again, all software that's running on the Pi. That also has access to the little button that you can't see. The one thing I would say is come up and have a look at this afterwards if you're interested. And it should, after a fashion, there we go. It should pause the clock when you push the button, and it should resume again when you push the button again. I appreciate that that's really hard to see, but hopefully you can imagine this. How are we doing? We're up to number 2, which means we're on to our final demo. And this is the one that I'm A, most excited about, and B, most disappointed with. Because this is my PiBot. I say it's mine. Right. The PiBot is basically using a very straightforward robot chassis. It's a robot, by the way, a rover, I suppose is the technical term. It's using a dirt cheap robot chassis. That was about $15 US, I think, the robot chassis with the wheels, the motors and the battery. It is using a Raspberry Pi. This time it's using a Raspberry Pi Model A. The Model A differs from the Model B in two main areas. One, it's slightly lower powered, both in terms of computing power, but also in terms of power draw. And B, it doesn't have an Ethernet port, and it only has one USB port. This has been designed basically for embedding in kind of hardware devices where you want to get the maximum runtime and you don't really need network ports and what have you. If you wanted network, by the way, you could do it via wireless via the USB slot. And he's booted up. The little red thing on top that is not Pi is called the PiBot board. And this has been developed by a guy called Dr. Simon Monk in the UK. And effectively, it allows you to extend the GPIO and the serial interface on the Pi through a nice safe set of electronics that mean that you can step voltages up to deal with things like motors. The Pi will quite happily drive a clock of its own. It's going to struggle if you ask it to start turning wheels. So this is basically a couple of controller chips, a series of capacitors, resistors, blah, 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 all the usual. That comes as a kit. That was soldered last night. So it's fairly straightforward to put together. I don't know if you can see, but that slots straight onto the GPIO. So we're using the exact same hardware. And let's see if it'll actually drive. Oh. Okay, do that.
Mojito.
Okay, it drives, sometimes it doesn't stop. This is actually a work in progress. The reason I say it's the most disappointing demo I've got is there was a ton of extra stuff that I really wanted to build onto it. I have a camera module that's ready to go on it, so you'll have a robot that can see. It's got a couple of ultrasonic rangefinders that will go on it, and it's also got a screen that should be on it to give you visual feedback, except I forgot the adapter, so I couldn't connect it. But anyway, that is the PiBot. What I suppose for me is the most interesting thing about that is that, believe it or not, I am not a hardware guy. I'm a software developer. I solder for fun. No, I don't solder very often at all. And I was actually able to, following some careful instructions, put together the hardware components for a robot that can, in theory, at the moment it's being controlled by a remote control. But in theory, that could be controlled via a wireless network. It can be controlled via GSM if you wanted to. You could be driving this thing around anywhere it's got a mobile network signal, and it could be taking photos, reporting back, all of that. And build cost for that one was, I'm going to get shouted at by my wife here, $83 plus shipping. And that included the Pi to go on it. Not bad if you wanted to make your first foray into building a rover. That concludes our 10 things in considerably over 10 minutes as it happens. At this point, are there any questions? Yo.
What's your power source for the PiBot?
6 of Duracell's finest. AA's. They are in a little caddy that's under there. You can't really see it, but that's basically a 6 AA cell battery caddy. I do have a plan to kind of bump it up to something a bit more NiCaddy lithium at some point, but for the moment that works perfectly well. Anybody else? That means I've either done a really good job or a really bad job. Okay, in which case, in closing, I will say www.damnfineraspberrypi.com is a site that I set up to kind of collate some useful resources. Slide deck and links to an awful lot of the stuff I've talked about, including the Bartendo and the videos and what have you, should already be live on that site. They'll also be going out on the TechTribes quiz list, so keep an eye on that. That's me. That's been the Raspberry Pi. Thank you very much.